Alright, so my name is Winsor Roy, and for my sophomore project, I did a game camera. I call it the Night Stalker. So a little bit of background as to where these will be set up on my farm. Probably the woods. I have a big mountain that I can put the game camera on. I also have food plots that I can put the game camera on a tree or something and see if I can grab a deer or two. I have lots of fields that I could also take pictures of deer if they come by or something. Right here is the system diagram that I've created. You have your motion detector, infrared LEDs. Those will be both out of the box, which will contain your Kinetis board, your new board. My new board has relay and transistor, but also has a boost converter as well. 6-volt pack, that's pretty good size, it's about that big. Camera pack for the camera and your camera. And with success, you should be able to take pictures as this one shows on the left. Discuss the electronic concept. So you have your 6-volt battery that controls your motion detector. If your motion detector senses motion, it'll turn on your Kinetis board, and with the stuff that I put on the new board with the relays and boost converter, the boost converter will convert 6 volts to 12 volts because the infrared LEDs take 12 volts in order to turn on. You have your battery pack, which is going to be outside the camera, so if they go dead, it'll be easy to change them and everything instead of trying to change them inside the camera as well. Here's my overall schematic. I will narrow on a couple things later on. I just want to show you what I created. These 4 are actually jumpers that go down to your microboard, which helps me instead of having numerous wires going down to that board. I really want to focus on the motion detector today because that is what triggers everything to turn on my wildlife game camera. So a little bit of what it looks like was what I have is right here. This is the actual motion detector that I'm going to be using. Right here, you can hardly see, so I pointed it out with arrows. You have your positive terminal from the switch. Everything will be turned on and off. Once you turn that switch on, your motion detector is on. Here's the output that goes to the microboard. Right here is a negative terminal, ground. There's 3 pins right here, and that will eventually be on the outside of the board. 3 things that I want you to kind of focus on this thing is the size, which is also small. 2, the output voltage is 3.3, but the big thing is the delay time, which is after you've gone through the motion detector, say you put your hand over it, it'll stay active for 5 seconds to 18 minutes, depending on how you turn up that little screw terminal. So again, I'm focusing on the motion detector. Here it is right here in my in my schematic. I narrowed in on it. So you have your 6-volt battery. Once you turn that on, this will trigger to turn this on, and only when it senses motion, then it'll turn on everything else, and this will help save your batteries instead of having everything on all the time. This right here is the range for this motion detector, 3 to 4 meters, which is about 13 feet to 18 feet off to the side. So say your deer comes in, usually they're not running, and especially if you have a food plot or something, you know, they're kind of walking in, nibbling a little bit, so I should get at least 1 decent picture out of that deer. So here's the 5 seconds to 18 minutes. I'm only going to use it for 12 seconds as I calculated because of the turning on the button and everything else, the time that it takes to do all that. The 18 minutes isn't really for what I need it for. That'll be more like for outside lights, motion detectors. This right here, I just wanted to show you that it actually goes lower in 5 seconds, but 3.64. That's just the waveform. Once you put your hand over it, it'll go high and then stay on for that amount of time. I need it for 12 seconds, which I'll show you later on. I just wanted to show you a little bit of the relay. I tested the two buttons on my camera, and the on-off button on my camera wasn't grounded, so I had to put in a relay right here. This diode is to protect once you turn off the button, help the current flow through to release. Also, both the diodes are actually to also protect if you put the batteries in wrong, it'll protect them. Here is the actual relay that I'm going to be using. Here are your commons, your coil, and your switch right there. I had to put it upside down so it looked like the picture itself. So here's a little bit of timeline of what actually is going to be working on, or going on. Here you have your deer coming in. Your motion detector senses the deer movement. Your camera turns on. Then your infrared LEDs, just because in case it's at night, so you can take pictures at night as well. The picture is taken, and then the infrared LEDs is off, and then the camera turns off. Here's some waveforms. So, as again, I told you that it was supposed to stay on for 12 seconds because the on-off button is 3 to 5 seconds to turn on the camera. The infrared LEDs has to be on during the time of the picture taken. So I did it 6 seconds while that's on for 3 to 4 seconds, and the overall is 11 seconds, so I just put it at 12 seconds to make it go up. So here's a little bit of my code. Right here is when I press down on the button, camera on, relay, your delay, and then your release of that button. Right here is the other button on the camera, the picture taken button. Again, it's the same idea. You take your picture, or you press down on the button, the delay, and then also your release of the button. So look at my main program for the for loop. So if the motion detector senses any motion, the button will turn on, the on-off button will turn on. Again, if you can remember, that's 3 to 5 seconds, so I put it at 6 seconds. Also, you want the infrared LEDs on, so I had to turn on the boost converter, which will turn those on. I delayed it, even though it was instant, I did test that. I wanted to make sure, so I did 100 milliseconds delay. Picture taken, again, that was 3 to 4 seconds, so I just delayed it at 6, just to be safe. And then turn off the boost converter, and if there's no motion, turn off. This is a first draft, and as you can see, in order to take a second picture, say if the motion detector detects another motion of that deer moving just a little bit more again, it has to power up that camera again. Eventually, I'm going to have another loop right here, so if it senses motion, it can just skip this 6 second delay, so it can just continuously go through this until there is no motion. So mechanical concepts, I measured it, should be around 14 by 6 by 4 inches, contained into a black box, and it should not be any more than 5 to 10 pounds. Eventually there will be a strap that goes around so you can wrap it around a tree or something. And also, if I really wanted to get adventurous, I could, grab some bark off some tree and kind of glue it around so it kind of blend in a little bit more. So the finished product, I took pictures of actually what would be in this box or outside the box. So you have your 6-volt battery right here. Here's your micro board. I haven't quite finished my new board, however, it's in the process, which will be put on right on that. Here is your batteries that will be wired into your camera. There's your ribbon cable that will connect into this so it can be controlled by your new board. There's your motion detector and your infrared LEDs that will also be connected into the box itself. So some overcome issues that I overcame. Definitely infrared filters. I actually went through 4 cameras. The first one was this blue one right here. It had 4 or 5 lenses before you could get to the actual infrared filter, and that was also cemented in. So I decided to buy another camera, or actually a buddy of mine gave me this camera, and I actually got the infrared filter out, but then again, once I put the batteries back in, turned it on, it was taking black pictures. So I went out and bought this black one, and then another buddy of mine gave me this one. I tore this one apart, and it was soldered on 3 parts of the board, and I didn't feel like resoldering everything. So, and then I tore the black one apart, and the same deal with the infrared filter being cemented in behind 5 different lenses, and a teacher of mine actually helped me out, and he got that out for me. The boost converter, it was high triggered, so no matter what, it was on the input to the output. So I figured out the second pin right here is the enable pin, which was connected to the VIN. Cut that so I can have a wire off from that, and it'll go into my add-on board, so it'll be low triggered. So impact on environment. What I'm hoping that this will help me on hunting for the upcoming season. Also youth weekend. I have quite a few nephews who love hunting, even though they get cold after a couple hours. But I take them out every year. This was such a great learning experience, and also it was helpful for me to use what I've learned in everyone's classes to put it all together and to build something actual with my own bare hands. I want to personally thank St. Dennis, because he was there for me for especially the last 3 weeks, trying to get this all together and building it and all. Mr. Correo, because he's the teacher who helped me get that infrared filter out. That was a big help for me. The class, because some of you actually helped me out with this project itself, you know, holding a wire or something, helping me solder or something. I want to thank you guys all. And also Bob for help cutting the board and everything. And if there are any questions, I'd love to answer them.
Any questions? So you actually laid out a board, right, at this point?
I've already cut a board out and everything, yes.
Okay.
This week is the week that I'm putting all the components on and everything, and then testing it. And then next week will be portfolio kind of stuff.
Okay. The 12-second waveform, can you go back to that?
Yeah.
So are you saying you set the motion detector to give you a 12-second
I
run?
will be setting it to 12 seconds
Oh, you will be?
in the upcoming, yeah, I haven't yet to set it. I'll have to hook it up to the oscilloscope and check it to see if it'll go 12 seconds. I might go a little bit longer, seems to, well, it'll be cutting it close to 11 seconds. I might go 13 or something, just to make sure.
But won't that, so are you doing that to guarantee you get 2 pictures of the deer? Because that's what's going to happen here, right? It's going to, if it's less than 12, then you only get 1 picture. If it's more than 12.
You mean if I put that loop in?
Yeah.
This was just to go with that, with the programming that I did. It was just meant for that.
Okay.
I will have to change this a little bit more, but this was just to make it easy for you guys to, you know, go back and forth.
Okay.
Because the code, I hadn't changed it. It was
Yeah.
first draft.
So I mean, I think the program you have now will work with the 4-second thing, right? It should work with the 4-second thing, so once you get it. Yeah, because once you start the process.
Oh, yeah, for the on-off button, yeah.
So,
The 12 seconds could be used for the 2 pictures, that's right.
right, okay. Yeah, any other questions? All right, thank you.